The Sahara was a completely different place during the Ice Age. There were rivers in it, there were lakes in it, it was fertile.
The Great Sphinx is one of the most recognizable monuments on Earth. A giant lion's body, a human face. For years, we believed it was built by the Pharaoh Khafre in 2500 BC. But when AI analyzed the weathering on the statue, the climate of ancient Egypt, and the strange proportions of the monument itself, it revealed something extraordinary. The Sphinx could be far older than we thought. Maybe from a time when Egypt was not the desert we know today, but a much wetter landscape shaped by heavy rainfall. A time before the pyramids, before the pharaohs, and before the civilization we know as ancient Egypt had even emerged. So how old is the Sphinx really? And if it really is older than we think, who built it? Let's find out. The official story. For centuries, the Great Sphinx lay buried beneath the sands of Giza, with only its head rising above the desert. That changed in 1817, when Italian explorer Giovanni Battista Caviglia started clearing the sand from around the monument. More extensive excavations followed in the 1930s under Émile Baraïs, gradually exposing not just the Sphinx, but the temples and causeway surrounding it. Once the monument was no longer isolated beneath the sand, archaeologists could finally start putting the story together. And piece by piece, everything began pointing toward the same ruler, Khafre. The conventional theory that eventually emerged was straightforward. The Sphinx was carved around 2500 BC, during the 4th dynasty, as part of Khafre's building complex. Its lion's body represented royal power and protection, while the human face was believed to depict the pharaoh himself. Archaeologists, including Mark Lehner, have spent decades excavating this landscape, uncovering worker settlements, bakeries, quarry marks, and countless other traces of the people who built Giza's monuments. The more of that landscape they uncovered, the clearer the picture seemed to become. Khafre's workers were here. They were cutting and moving enormous quantities of limestone. They were constructing temples, causeways, and monuments across the plateau. And right in the middle of that enormous complex stood the Sphinx. For most Egyptologists, it was case closed. But there was one problem. No inscription or surviving record tells us when the Sphinx was built. The only major clue comes from a granite stele placed between its paws by Pharaoh Thutmose IV, around 1401 BCE. By then, the Sphinx was already an ancient monument. It tells us nothing about who carved it. It also gives us no evidence of when it was made either. Researchers were once again back at square one. But that was when an interesting discovery in the stone itself caused them to take an old theory seriously. And the more they looked, the more they realized the Sphinx might be telling a very different story than the one archaeologists believed. Written in stone. When you look closely at the walls surrounding the Sphinx, the mystery becomes even harder to ignore. Deep channels run down the limestone in rounded, uneven patterns. In some places, the rock looks as though water once moved slowly across its surface, wearing it away over an enormous span of time. For geologist Robert Schoch, those marks raised a much bigger question. What if the Sphinx had been exposed to a climate very different from the desert we see today? The idea wasn't entirely new. Back in the 1960s, French scholar René Schwaller de Lubics had already pointed to the unusual weathering around the Sphinx. Decades later, independent researcher John Anthony West returned to the idea and asked Schoch to examine the monument from a geological perspective. In 1991, Schoch surveyed the Sphinx enclosure and carried out seismic testing with seismologist Thomas Dobecki. What he found convinced him that something about the conventional timeline didn't add up. Schoch argued that the weathering patterns were difficult to explain through wind and desert conditions alone. Instead, he believed the limestone showed evidence of prolonged exposure to rainfall, and that created a problem for the conventional story that places the Sphinx's origins in 2500 BC. At that time, the Giza Plateau was already living under a much drier climate, so if heavy rainfall had really carved those channels into the enclosure, the weathering might have happened before the desert became the landscape we know today. That was an ambitious theory, because the last time Egypt had such heavy, sustained rainfall was in 7000 BC, thousands of years before Khafre and the Pharaohs. But there was a problem with that argument too. Other researchers saw the same stone and reached a very different conclusion. Archaeologists and geologists, including Mark Lehner and K. Lalgori, argued that groundwater, surface runoff, and differences in the limestone itself could produce much of the weathering Schoch was pointing to. For decades, neither side could produce evidence strong enough to completely settle the debate. Then, in 2025, something very different entered the picture. Not another archaeologist, not another geologist. A machine. Artificial intelligence was brought in to analyze evidence on a scale no individual researcher could manage alone. And what happened next would take the mystery in an entirely different direction. The Grok analysis. The machine wasn't given a simple question. Grok was presented with a collection of evidence surrounding the Sphinx, including geological surveys, laser scans, climate reconstructions, astronomical calculations, and archaeological measurements. The goal was to see whether all of that information could help distinguish between the two explanations researchers had been arguing over for decades. Was the weathering simply the result of thousands of years in the desert? Or did it point to a much wetter period in the Sphinx's past? And according to the analysis reported by the researchers, the answer was striking. Grok found the erosion around the Sphinx more consistent with prolonged rainfall than with ordinary desert weathering. But the AI didn't stop there. It took the analysis one step further and asked the next big question. How old would the Sphinx have to be for that explanation to work? Grok considered how long the monument would need to remain exposed to rainfall to produce the kind of weathering visible in the enclosure. Then it compared that with the climate history of the Giza Plateau. The result pointed toward a date thousands of years earlier than the conventional timeline, around 7000 BCE. That was exactly the date Robert Schoch had proposed more than 3 decades earlier. If that interpretation is correct, the Sphinx wouldn't simply be an ancient Egyptian monument. It could be the remains of a much older structure, created when Giza was still a very different landscape. But there was still a problem. Rainfall alone couldn't tell us what that older Sphinx actually looked like. If the monument really had a history stretching thousands of years further back, then perhaps the stone itself contained other clues. And there was one feature researchers couldn't ignore. It was sitting directly on top of the lion's body. The missing head stand in front of the Sphinx. And one detail is difficult to ignore once you notice it. The body is enormous, a sprawling lion carved directly from the bedrock. But the human head above it seems strangely small. Researchers have argued that if the head had been carved to match the scale of the rest of the monument, it should be considerably larger. So why isn't it? One possibility is that the Sphinx didn't always have this head. Schoch and other researchers have proposed that the monument may have originally been carved as a lion, with the head later reshaped into a human face. If that happened, the sculptors wouldn't have been starting with a fresh block of limestone. They would be working with an older monument, one whose original head had already been worn down by centuries of exposure. The best way to repair it may have been to cut away the damaged stone and carve a new face from what was left. But there is another possibility. Perhaps nothing was recarved at all. The upper part of the Sphinx is made from softer layers of limestone than some of the rock beneath it. Over thousands of years, weathering could have worn the head down far more aggressively than the harder stone forming the body. In that case, the strange proportions wouldn't be evidence of a second sculpting. They would simply be the result of time. And that's where the problem becomes difficult. Both explanations can account for the head we see today. But if the first possibility is correct, then the small head isn't just a strange feature. It's evidence of a transformation. And that changes the question completely. Instead of asking why the Sphinx has such a small head, we have to ask something much more difficult. What was here before it? To answer that, researchers needed clues that could not be damaged over time. Clues that would not change even over thousands of years. And something that has never changed ever since the Sphinx was made is where it is looking: east. That's when they finally started noticing that the Sphinx has always been looking in a very specific direction: east. The search for answers. The Sphinx doesn't simply face east. It faces the eastern horizon, directly toward the place where the sun rises. For the ancient Egyptians, that direction was anything but random. Sunrise represented rebirth and renewal, and the daily journey of the sun was deeply woven into Egyptian religion. A monument facing east could therefore carry a meaning far beyond simple orientation. But once researchers began looking at the Sphinx through the sky above it, the theory became much more ambitious. Earth's axis slowly shifts over a cycle of roughly 26,000 years, gradually changing where stars appear in the sky. And that opened the door to a controversial idea. Researchers Graham Hancock and Robert Bauval proposed that the Sphinx's lion form could have been connected to the constellation Leo. They argued that when the monument's orientation was considered alongside the changing position of the stars, the evidence could point toward an era around 10,500 BCE. That is when the constellation Leo was positioned directly behind the rising sun. And there is a reason the idea has remained so compelling. The ancient Egyptians clearly watched the sky. Their temples, pyramids, and tombs were often carefully oriented, while celestial movements played an important role in their religious beliefs. So an astronomical connection isn't impossible. But there is a crucial difference between something lining up with the sky and the builders deliberately designing it that way. Until we find an inscription or record that tells us, there's just no way to confirm if it is coincidence or intentional. So, scientists had to move on from the sky and start looking in other places. But if the sky can give a genuine scientific theory, what about the ground the Sphinx has been sitting on for more than 4,000 years? That line of thinking brought researchers to a study conducted more than 30 years ago. During seismic surveys in 1991, Robert Schoch and seismologist Thomas Dobecki reported unusual readings beneath the Sphinx enclosure. Their equipment detected areas where seismic waves appeared to travel more slowly through the rock, including a possible cavity near the Sphinx's left paw. The reported anomaly measured roughly 12 by 9 meters and extended several meters below the surface. To Schoch, that possibility was significant. If the Sphinx really did have a much older history, then an undiscovered chamber beneath it could potentially contain evidence that the monument could not. But there was a problem. The cavity was never excavated, meaning nobody could find out what was actually beneath the enclosure. The unanswered clues around the Sphinx kept on adding up, and they forced researchers to look beyond Egypt entirely. Because if the Sphinx has that many secrets, then what about these other monuments that have been around for even longer? Beyond Egypt. Once you entertain the possibility that the Sphinx could be older than the conventional timeline suggests, another question follows. Was Egypt really the beginning of monumental construction? For a long time, the answer seemed obvious. It was. Then archaeologists began uncovering something that complicated that picture. Long before the pyramids rose at Giza, people in other parts of the world were already organizing themselves to build structures on a remarkable scale. One of the clearest examples is Göbekli Tepe, built between roughly 9,500 and 8,000 BCE. It shows that hunter-gatherer communities were already constructing enormous monuments thousands of years before the pyramids. That alone forced archaeologists to rethink what prehistoric societies were capable of. But that wasn't the only example. Thousands of years after Göbekli Tepe, Stonehenge showed that prehistoric communities in Britain could transport enormous stones over long distances and deliberately align monuments with the sun. Much later still, builders at Sacsayhuaman in Peru fitted enormous stone blocks together with remarkable precision, often without mortar. The cultures were different. The continents were different. The dates were different. But the ability to organize people, move enormous stones, and build on a monumental scale was there. And that's where the comparison becomes tempting. If humans were capable of monumental construction thousands of years before the pyramids, perhaps the idea of a much older Sphinx isn't as impossible as it first sounds. Some have even suggested these sites preserve knowledge from a lost civilization. But that's all it is. A comparison. The similarities may be interesting, but they don't tell us that these cultures shared the same knowledge, let alone that they came from a common civilization. There is no established archaeological link connecting Göbekli Tepe, Stonehenge, Sacsayhuaman, and the Sphinx. They were most likely created by different societies in different places for different reasons. These monuments don't prove that the Sphinx is older. They don't reveal a lost civilization. What they do prove is something much simpler. The ancient world was capable of far more than we once assumed. And if the Sphinx really does belong to an earlier chapter of human history, then its age may not be the most important question anymore. Because we wouldn't just be asking, who built the Sphinx? We'd be asking something much bigger. Who was here before them? What we still don't know. By this point, the Sphinx has given us several reasons to question the simple version of its story. The weathering, the unusual proportions, the astronomical theories, and the possibility that some of the evidence we would need to settle the debate may no longer be visible. That last possibility is where the story gets even more complicated. The theory that is often brought into discussions of humanity's forgotten past is the Younger Dryas impact hypothesis. It proposes that roughly 12,800 years ago, a cosmic impact triggered rapid cooling and environmental disruption. Supporters of this theory point to unusual concentrations of platinum and other impact-related material, but the idea remains heavily disputed, with no confirmed impact crater. But the hypothesis tells us something else as well. It shows us how the last ice age came to be. And that is very important, because the end of the last ice age changed the planet forever. As enormous amounts of ice melted, global sea levels eventually rose by roughly 120 meters, flooding huge areas of coastline that had once been dry land. And that creates a genuine problem for anyone trying to reconstruct humanity's earliest history. Some of the places where ancient people lived may simply be underwater today. We already know that submerged archaeology can reveal traces of human activity that would otherwise remain hidden. Sonar surveys in the Gulf of Cambay have produced images that some researchers interpreted as possible man-made structures. Off the coast of Japan, the Yonaguni Monument has similarly divided researchers between human construction and natural geology explanations. Neither site provides evidence of a lost global civilization. But they demonstrate something more important for this investigation. We can only see part of the ancient world today. Some evidence has been buried, some destroyed, and some may now be sitting deep beneath the ocean. But just because we don't have access to the world thousands of years before us, doesn't mean the Sphinx is older than we think. The conventional theory still has substantial archaeological evidence connecting the monument to Khafre and the 4th dynasty, while the opposing geological argument points to weathering that may suggest a much earlier date. And after decades of debate, neither side has produced the evidence needed to settle the question. Which brings us back to where this story began. AI. Grok didn't uncover a hidden chamber. It entered an existing debate and reportedly found one interpretation of the geological evidence more convincing than another. That's interesting, but it isn't proof. What we have is a monument whose archaeological context points toward 2500 BC, and the geological evidence puts it at 7000 BC. And after decades of debate, neither side has produced the piece of evidence that ends the argument. So after everything we've uncovered, we're left with the question that has survived every theory, every excavation, and every new technology brought to the problem. How old is the Sphinx really? For now, there is no definitive answer. And perhaps that's why this monument remains so fascinating. It has stood above the Giza Plateau for thousands of years, watching civilizations rise and disappear around it. We've scanned it, measured it, studied its stone, tracked the stars above it. And now we've even asked artificial intelligence to examine its evidence. Yet somehow, after all of that, the Sphinx is still keeping part of its story to itself. Grok didn't crack open a hidden chamber of lost history, and it didn't hand scientists numbers they'd never seen before. What it did was pull a real 30-year-old geological argument back into a conversation most people never knew was still open. So, what do you think? Does that change how old you think the Sphinx really is? Or does the case for Khafre still hold up for you? Let me know your thoughts about this in the comments below. And if you enjoyed this video, make sure to like, subscribe, and turn on notifications so you never miss the next mystery we dig into. Thanks for watching, and we'll see you in the next video.